subscribe my channel and press the bell icon to get new video.
Hi friends, now I am going to discuss about KVL, Kirchoff's voltage law. So, its statement. It states that the algebraic sum of EMF is equal to the algebraic sum of IR drop in a closed loop. Okay? The algebraic sum of EMF is equal to the algebraic sum of IR drop. Okay? We know in a circuit, suppose in a circuit, here I am drawing a circuit. Look at this figure. Suppose it is negative and it is positive. Okay, here is a resistance, here is a resistance. It is connected. Okay, it is E1, it is E2, it is R1, it is R2. Okay, now it is a circuit. In this circuit, two EMFs are connected and two resistances are connected. Okay, so due to two EMF, one current will flow in the total circuit. Okay, suppose that is I1, that is I1 current is flowing. Okay, so I1 current is flowing through the total circuit. At the place of R1 or at R1, this I1 will make, or this I1 and R1 will make a voltage drop, that is V1 I1 R1. At R2, that is suppose V2, that is I2 R2. Okay, so now the statement is saying in the closed loop, it is a closed loop or closed circuit. In this closed circuit, the algebraic sum of EMF is E1 and E2, means E1 plus E2 is equal to the IR drop, the algebraic sum of IR drop. So IR drop is I1 R1 and I2 R2. These are the IR drop. So its algebraic sum means I1 R1 plus I2 R2. So according to the statement, E1 plus E2 is equal to I1 R1 plus I2 R2. So according to the statement, we can write E1 plus E2 is equal to I1 R1 plus I2 R2 plus I2 R2. Okay, this is the KVL. It is the proof of KVL. So remember, KVL means Kirchoff's voltage law, but KCL is Kirchoff's current law. That law deals with the current and this law deals with the voltage. Okay, so KVL is Kirchoff's voltage law. In this law, the algebraic sum of EMF is equal to the algebraic sum of IR drop. Okay, so lastly we can write summation of E equal to summation of IR. Summation of E means summation of EMF. Summation of IR means the algebraic sum of IR drop. Okay.